Hi, my name is Whitlow, and I will be presenting the DP3 for Rattler Productivity Solution, or otherwise known as Team 14. So the first thing we did as a team was create a mission statement. This contained our product description, benefit proposition, key business goals, primary and secondary markets, assumptions, and stakeholders. We used all these things going forward to determine what exactly we wanted to do with this product. We wanted to create a device that vibrates on our desk to keep you alert when studying for long periods of time. We wanted to obviously make money doing this. And we were going to be selling primarily to students, but also partially to office workers. After that, we created a fictional customer. We made a customer profile for a tired college student. Over here on the right, you can see that we went fairly in depth with this made-up customer, but for all intents and purposes, all that matters is that it's a college student, they're tired, and they want to get their work done on time. Next, in a similar setup, we came up with a use case for the device. This was just a real quick summary of how this would be used in a couple different ways. The majority of the time, the device would just be turned on, used, and then turned off. Nothing too complicated. Next, we came up with the customer needs. We got these by surveying college students, which is, as I mentioned before, our target demographic. We then compiled, interpreted these, and then we assigned them primary and secondary consideration as to how important we felt they were. After that, we came up with concepts. We came up with different ideas for a power source, an activation method, and an output signal. Then each team member picked two paths through these concepts we came up with and illustrated them, which we then took to the concept scoring and concept selection phases. We cut it down to from 6 to 3 using concept screening, and then concept selection. We scored each method until we came to the conclusion that a device with percussive instruments like beans, rice, or beads inside of it, and computer powered and activated, was the route we wanted to take. After that, we developed specifications. We came up with how powerful we wanted the motor to be, how large we wanted the device to be, and a few other things. Finally, we created CAD models, as you can see here on the right, and this is what the final design, this is how it works. Essentially, in these two compartments that you see in the bottom right, one will contain a control chip and the other will contain a motor. On the end of the motor will be the percussive instrument. It'll rattle around like a maraca within the device at a periodic time, semi-randomly, as set by the control chip. The power will be fed in through the small hole in the bottom from a computer USB plug. But with all of that said, as we moved into the final stages of development, we had to do a few more things. Firstly, and most notably, we had to make sure that there were no intellectual property violations. We scoured the patent office. We looked at all the different patents that could be similar to our product. And the closest things we came up with are shown here. One was just a task manager. That's the thing on the bottom. It was never actually brought into fruition, as you can see from the very basic diagram that they provided. And the other was a phone lockbox. We felt this was similar because it's a productivity helper, small, fits on your desk. However, these and everything else we could find, nothing really came close to our device, and we were free and clear from patent violations. Then we came up with a failure modes and effects analysis. This showed us where our device could fail, how likely it was to fail, what we could do to fix it, and how bad it would be if we didn't fix it. Then we moved on to calculating the time and cost of assembly. We estimated that it would take 150 seconds to build the first unit, given that the assembler had all the pieces. and it would take $15 an hour to pay the workers to do it. We come up with $55 to assemble each unit. Next, we came up with a bill of materials where we estimated the materials and the price of each of the materials. Now, moving forward, we would certainly want to lower this. This was simply for the prototype using store-bought parts. Next, we went into NX, the CAD software, and created models of our product. The top left product, you can see, is what it will look like from the outside. And then we hid the outer shell so that you could see the insert and see what's on the inside of this product. Then, after that, we were able to construct a functioning prototype. Now, as you can see, it's not a very pretty prototype. What you're looking at here is a battery, a can of cola, a motor inside of that can, some beads also inside of the can, and then a very simple wiring and circuitry setup. That is then plugged into the computer, which was running one of our programs that allows us to create that random element, create those random vibrations with the motor. Now, this is obviously very, very rudimentary, but without access to 3D printers or other on-campus things to help us build this, it was really the best we could do in the time constraint. Now, attached at the bottom, I've left in the CAD model so that you can hopefully see that everything that's there would be compacted and fit inside of that small rattlesnake tail shaped device. And then, speaking of going forward, we took time to reflect after we had done our project, and we came up with, let's say, version 2.0. We came up with what we're going to have to change going into the future. Now, obviously, like I mentioned before, the prototype was very much a prototype. It's not extremely functional. Well, it is functional, but it's not extremely pretty. It wouldn't, so the first step would be to obviously get everything inside of the shell and beautify everything. The next thing that we have to do, we have to cut costs. I mentioned that when I talked about the bill of materials, but everything we were using is simply too expensive. We need to find the cheapest plastic, cheaper circuit boards, and other things that can lower the cost. Now, obviously, without having to create the mold, things will get a lot less expensive. That mold is only required when you make the first one. That said, it's still pretty expensive. So we need to lower costs in every way aspect we can. Then lastly, I wanted to talk about how going forward we want to create a secondary Rattler device, one that's not reliant on a computer. So we want to make it so it can be controlled by a switch and battery powered, which, yes, you saw we eliminated earlier with concept screening and selection. But we were perhaps too harsh on the design. That said, that will then bring in, again, cost cutting and making sure everything fits inside of the CAD model. So there may need to be some refinements made there. Thank you for your time. This has been the DP3 presentation for Team 14, Rattler Productivity Solutions, and I wish you a good summer.